Welcome to EDU World Space.
In order to calculate the diameter of blade necessary to produce 10 megawatt of power, so in that case I can write the kinetic energy equation as delta T is equal to 1 half delta mv square. Now let's divide this equation by the time from both the sides. So we will get the energy rate, or we can say that the power. So delta T by time delta T is nothing but the energy rate, or you can say that the output power is equal to 1 half as it is because it is the constant value. There will be a derivation of mass, so I can write dm upon dt into v square. But as we know, the mass rate formula dm upon dt is nothing but rho a v square. So instead of that, I can write 1 half rho a v square into v is equal to 1 half rho a v cube, because there is a multiplication of v square and v. Let's say the equation number 1. This equation we are going to use for the further calculation. So I can write dt upon dt is equal to 1 half rho a v cube. Okay, moving further, the output power is P is equal to eta times dt upon dt. Here in the equation, P is the output power, eta is the efficiency, and the capital T represent the kinetic energy, and small t is a time. And dt upon dt represent the energy rate, or you can say that the power. Let's say this one as a equation number 2. Okay, now we will substitute equation 1 into equation 2. So here instead of dt upon dt, I can write this whole term here. So for the first case, let's say the power P1 is equal to eta times, now dt upon dt is R 1 half rho a v cube. But here we have considered it P1, so we will write the A1 v cube. Let's say equation number 3. So this equation is for the first design. Now for the second design, the power will be P2, and similarly we can write the efficiency eta. Here efficiency will remain same, so you can write eta 1, eta 2, or eta all are equal. Now again 1 half rho, instead of area A1, now in the second design the area will be changed, so I can write A2 and the V cube as it is. Let's say this equation number 4. Okay, now we will divide the equation 2 into equation 1. Or you can say that let's take the ratio of equation 4 to equation 1. So I will get here P2 upon P1 will be is equal to eta times rho A2 V cube upon 2, and the P1 will be eta times rho A1 V cube divided by 2. Okay. By simplifying this one, I will get the answer, that is, here the efficiency is same, so that will be cut. 2 will be cut. The density will also cut. V cube is also same, so this value will be cut. So finally I will have A2 upon A1. But as we know, the area is pi by 4 d square, and as we know the pi by 4 is also constant quantity. So in numerator and denominator, the both will be cut it out. So finally I can write, instead of A2 there will be a D2 square, and instead of A1 there will be a D1 square, which is nothing but my design of power 2 and the power of design 1. Okay, now let's substitute all the values in this equation. So finally we will get the answer of diameter 2. Okay, so let me rewrite this formula in the form of d2. So my d2 will be is equal to square root of p2 upon p1 times d1. Okay, let's put all the values here. So I will get my power of design 2 is 10, and the power of design 1 is 1.5, and diameter d1 is 82.5. By calculating this, I will get the diameter d2 will be 213 meter. So this is nothing but my d2.